You know, annulenes are monocyclic fully conjugated molecule. In this video, I will discuss the aromaticity of different annulenes. Annulenes, has the general molecular formula either CnHn or CnHn plus 1, where N is an even number in the case of CnHn and N is an odd number in the case of molecular formula CnHn plus 1. For example, the simplest annulene is cyclobutadiene. It is 4 annulene, cyclobutadiene. Benzene can be regarded as 6 annulene because it has the molecular formula C6H6 and 4 annulene has the molecular formula C4H4. Okay, and so generally annulenes are monocyclic fully conjugated molecules with the general molecular formula either CnHn or CnHn plus 1, where N is an even number in the case of general molecular formula CnHn and N is an odd number in the case of annulene with the general molecular formula CnHn plus 1. Now we will consider the aromaticity of 8-annulene. If it is planar, we can represent the molecule like this. But it is not planar because it has a large bond angle about 135 degree. Even though it contains 4 pi bonds and carbon atoms are sp2 hybridized, the planar structure will be having large bond angle 135 degree. And so it causes very large angle strain and assumes non-planar tub-shaped geometry. In tub-shaped geometry, the angle between C double bond C single bond C is 126.1 and C double bond C single bond H is 117.6 degree. The tub-shaped structure can be represented like this. Okay, and this is not planar and hence it is not aromatic and neither antiaromatic. Not aromatic or neither antiaromatic. So it is called non-aromatic molecule. Okay, next higher homologue of annulene is 10-annulene. Its planar structure can be represented like this. All the double bonds are cis to each other. These double bonds are arranged cis to each other and hence the molecule is having a lot of angular strain and hence it assumes a tub-shaped structure. In tub-shaped structure, one of the double bond is trans while all the other bonds, only one bond is trans while all the other bonds are cis to each other. And hence there is much angular strain in this ring also. And so 10-annulene assume this structure and this structure, the two double bonds are trans to each other, this double bond and this double bond, and these are trans to each other. But here are two hydrogen, this hydrogen and this hydrogen are facing each other inside the ring, which poses a large steric hindrance to each other. Thereby the molecule lost the planarity and it attains a puckered ring structure. And hence 10-annulene, even though it has Huckel number of pi electron, it is non-aromatic in nature. But the planarity can be attained by removing the hydrogen at this position by a CH2 group. This CH2 group is bridged between this carbon and this carbon and hence it is called nan-10 methane 10-annulene. And this nan-10 methane 10-annulene is aromatic. The planarity is regained by the removal of two hydrogen from these positions, 9 and 10 position. And alternatively, a CH2 group is locked between this carbon atom, 9 and 10 carbon atom. It is called nan-10 methane 10-annulene, which is aromatic in nature. The aromaticity also can be attained by the removal of these two hydrogen and by locking this carbon and this carbon, nan-10 carbon, by an oxygen atom also. For example, nan-10 oxa 10-annulene. It is also aromatic. Similarly, we can lock this carbon and this carbon, 9 and 10 carbon, by an NH group. Thereby we will get nan-10 aza 10-annulene, which is also aromatic. The next higher homologue is 12 annulene. This can be represented like this. It is planar. These three hydrogens are far apart to each other and avoiding the non-bonding interaction. Hence do not create any strain for the planar arrangement. Normally it is having 4 and pi electrons. That is 12 is Hückel number, 4 and pi electron, and hence it is antiaromatic. It is planar, obeys Hückel rules, that is 4 and pi electrons rule, and hence it is anti-aromatic according to Huckels. Okay, 12 annulene is aromatic. Then we can take the next annulene, 14 annulene. It is the structure of 14 annulene, but it is non-aromatic. Non-aromatic. Even though 14 is a Hückel number, 4n plus 2 pi, according to 4n plus 2 pi rule, that is, it should be aromatic, but these hydrogens are closer enough to pose angle strain for the planar arrangement, and hence it is non-aromatic because planarity is lost because of the interaction of hydrogen atoms, the internal hydrogen atoms between each other. And hence 14 annulene, even though it is having Hückel number of pi electron, planarity is lost because of the presence of interaction between the hydrogen atoms. Okay, so 14 annulene is non-aromatic in nature, but the dihydro 14 annulene is aromatic in nature. Dihydro 14 annulene is formed by removal of two interfering hydrogen, leads to the formation of a triple bond. Here is a triple bond is formed by removing the interfering two hydrogen, one hydrogen here and another hydrogen from here. And by removing the interfering hydrogen, we'll get a triple bond between this carbon atom, and these two electron from the newly bonded pi bond of carbon-carbon triple bond are delocalized into aromatic system, and thus the molecule becomes aromatic. The other pairs of pi electrons does not interact with the delocalized pi electron system, and it is at right angles to the conjugated system of pi electrons. Only this newly formed the pi electrons of the newly formed pi bond is associating with the delocalization process. Okay, that is why the dihydro 14 annulene is aromatic in nature. Next higher homologue of annulene series is 16 annulene. Its structure can be represented like this: 16 annulene. 8 pi bonds are there. 16 is a Hückel number for anti-aromatic property. That is 4n, it obeys 4n pi rule, and hence it is anti-aromatic. It is planar, cyclic, conjugated pi system, but with the 4n pi electron. That is 16 is a Hückel number with the 4n pi system where n is 4. There are 16 electron, and hence it is anti-aromatic. The next homologue is 18 annulene. It can be represented like this: 18. 18 is Hückel number for aromaticity. That is, it obeys 4n plus 2 pi electron rule. So 18 is Hückel number for aromatic, and hence it is aromatic. All the internal hydrogens are far apart each other in order to have these hydrogen do not pose any steric hindrance, and hence the molecule is planar to allow complete delocalization of these pi electrons, and hence it is aromatic. Okay, all the higher homologues are planar. They are cyclic in nature with the conjugated pi bonds and obeys Hückel rule. If it has 4n pi electrons, it will be anti-aromatic. If it has 4n plus 2 pi electrons in the system, then it will be aromatic. For example, see 20 annulene. 20 is Hückel number with the 4n pi system, and hence it is anti-aromatic. 22 annulene. 22 is Hückel system with the 4n plus 2 pi electron, and hence it is aromatic. 24 is a 4n pi system, and hence it is anti-aromatic. 26 pi electron is a 4n plus 2 pi electron system, and hence the 26 annulene is aromatic in nature. Okay, I hereby conclude my video here. Thank you for watching. If you are not yet subscribed to my channel, please subscribe and share this video if you like it to your friends. Thank you.